In a post-Cold War world of shrinking space budgets, NASA's Jet Propulsion Laboratory in Pasadena, California, was challenged to reinvent itself. The lab's new assignment from NASA: land safely on Mars in a revolutionary new way.
Mars is the hardest planet to land on, and I want you to do it cheaply.
But could it be done? And who was brave or foolish enough to sign up for such a risky mission?
Nobody else wanted the job. They were afraid to death of it.
The rest of the lab was going, what are these guys doing? Because all they could see is the most embarrassing failures possible.
Added to the challenges was the addition of an unexpected passenger.
That silly little rover. It was not popular with anybody.
Command air, what's going on now? What's broken now? This thing's falling apart on me.
If you crash, you're gonna crash and burn big time.
You're not allowed to fail. Don't you dare fail. Do whatever you need to do, but don't fail.
Here to JPL in Pasadena, California for the 20th anniversary of Mars Pathfinder, the mission that began what is now a continuous presence on Mars 24/7 for 20 years. Now, to celebrate this achievement, we have with us some of the movers and shakers and doers who made Pathfinder possible. So if you will, hold your applause until after I've introduced them all. Here on my left is former NASA Administrator and the longest serving NASA Administrator, Dan Goldin, former JPL Director Ed Stone, former JPL Director Charles Elachi, and on this side, current Director Mike Watkins, and two of the very most important folks that worked on the engineering side of Pathfinder, the doers that made it work, Jennifer Trosper and Brian Muirhead. Would you please give them a warm welcome? Thank you. That is indeed a warm welcome. Yeah. So Mike, why don't you start us off? What is it about this place called Mars that's so special for people?
You know, I think Mars holds a special place in everyone's heart because it looks a lot like the Earth. I mean, it looks like a place we could live. It looks like a place that we understand and we could be at home on. And you know, it begs the question of what was its history and how did it get the way it is? And you know, could there have been life there? Could it have been habitable? And you know, I think it goes back a long time that people have wanted to answer those questions and to get there. And you know, I believe that Pathfinder in particular, you know, it helped us understand a new way of exploring planets. You know, you could argue that Viking as the first planetary lander sort of pioneered in situ science, but that was kind of a one-off mission. And I think Pathfinder showed us not only that mobility can be useful, but the notion of an ongoing interactive exploration of a planet, a voyage of discovery, a mission of discovery, of continuous discovery, is something that we really learned from Pathfinder. And not only have we continued to extend that legacy, as you mentioned, for 20 years on Mars with bigger and better rovers as we try to understand and unlock the mysteries of Mars and answer these questions, but it's a paradigm that we talk about using even for Europa now. We talk about how do we do an interactive mission of discovery on other planets, on these ocean worlds. You know, how can we emulate this Mars mission of discovery in other places that are just as fascinating as Mars?
Now, I'd like to set the stage now as we go back 20 years to a very different time when a lot of change was happening. And I think this clip you're about to see will set it nicely for us.
In 1989, the Berlin Wall fell, marking the beginning of the end of the Soviet Union, the end of the Cold War, and the beginning of a decade of shrinking budgets for America's space program. And that meant major changes, declared the new head of NASA, Dan Goldin.
It is scary. I can't promise that everything's going to be okay.
To the shock of many, Goldin predicted that the space agency's very survival was in doubt unless it embraced change.
But I can promise that if we go for the survival mode, as an agency in 5 years, we're dead. So let me walk you through some of the issues.
Goldin delivered the same message at JPL.
And we'll never ever go back. JPL will never ever look like it did. You will not build very many spacecraft that look like this. You got to erase that from your mind.
He wanted JPL to show how all of NASA could approach its work differently in the post-Cold War world. A concept Goldin called faster, better, cheaper.
Part of his charge was, in fact, to oversee the transition of the agency to a new direction, new scale missions, and science in particular.
The Jet Propulsion Lab is going to be the catalyst to change the whole NASA space program.
So I was trying to understand exactly what kinds of things he was trying to promote and how we could then make them real. Our job was to make them real.
My words was I wanted to darken the skies with a lot of satellites and spacecraft, and I wanted the American people to share in the excitement. And the first thing they did was the Mars Pathfinder. Brilliant, brilliant.
So Dan, you came out here, and in some of those same talks, you talked about the change that was happening was at the speed of light. And you told a story about going to Russia and visiting a facility. I wonder if you could tell that story.
I was sitting in my office in early June, and I got a call from the vice president, and he said, I'd like you to show up at Blair House. I went to Blair House, and I walked in, and I saw Yuri Kopchev, the head of the Russian Space Agency, standing outside. And I said, Yuri, what's going on here? I don't know where I'm going. And he said, well, the head of the National Academy of Sciences of Russia wouldn't let me into the meeting. I walk in, and there is Boris Yeltsin sitting on the other side of the table, and a whole variety of people from the Russian Space Agency, and me. And I walked up to Boris Yeltsin through a translator and said, my colleague, Yuri Kopchev, is not allowed in the room. And the head of the National Academy of Sciences from Russia, he had flames coming out of his nostril. It was unbelievable. And they asked Yuri to come in, and I was then working for President George H.W. Bush, Bush 41. And he was very concerned, as was President Clinton, as was Bush 43, about the Russian pride in their space program, and that their economy had crashed, which is why the Cold War ended, and he wanted me to bring our programs together. And I worked with Boris Yeltsin to come to Russia, and I knew I was going to be transferring funds to Russia to help them. So I asked him if he'd take me into the SS-18 factory, which I knew a lot about, and that's where they built the giant multiple warhead vehicle in Dnepropetrovsk at Uzhnaya. So he opened up the whole Russian space program to me, and it was weird because I went against Russia for 25 years, and I designed a lot of systems that I can't talk about, but...
Some of them were targeting that same place, right?
Hypothetically.
And during your confirmation hearings, you went around and made your visits to various senators, and Senator Hollings, I think, kind of pictured or painted a sort of dire picture of this job you were thinking about taking on. It was, this is why you felt there had to be this sort of revolution, did you not?
Well, I'll tell you, I was pretty excited, but I knew it was problematic. And I knew it was going to be really hard when I walked into the office of Senator Fritz Hollings, and he told me to sit down, and he drew a chart on the wall. And on the ordinate was billions of dollars, and on the abscissa was years. So he started in 1992, and he drew a straight line up that went to 2002, and it started at 15 billion, and it went to 25. And then he went to 1992 at 15 billion and drew a straight line across. And he said, if you want to be confirmed, you're going to sign up to a no-growth budget. I said, but that's $50 billion. He said, you'll sign up to that or there'll be no space program. What do you want to do? And then he went on to say, the shuttle is grounded. It's got hydrogen leaks. The space station spent all their money and all the time. They have nothing. Galileo is deaf on its way to Jupiter. Hubble is blind. And the weather satellites are dead. Are you sure you want this job? And I said, you bet. I said, because money is not the magic ingredient, and that we need to reinvigorate the science and technology creativity of the NASA team. And they haven't been allowed to do that. I'm signing up.
Ed, you had a similar sort of realization when you were coming into the job and you went to visit Washington and OMB, and you had a stark realization too.
That's right. When I agreed to be director was the summer of 1990. It started in January 91. The program was exactly as you described it, like that. It was going to double into basically a 10-year period, and it was clear the job I had was how to handle all that growth. But a visit to Washington taught me in the early 91 already that except for NASA, which still believed this was the future, the rest of the Congress and the White House was saying, that's the future.
It was a crisis.
And I know that you and Ed worked very closely on this, and Ed, you, when given this opportunity to take on Pathfinder.
We worked closely, but he executed. Yes, I gave directions.
That's right. That's right. It was to make it real, as you said in the clip.
That's right. 3 years to launch, less $150 million. Land on Mars, $150 million. Now, it had a rover, which they added 25 for, because, again, that was part of the advanced technology. But it was a challenge, clearly. It was a major challenge and a major risk that the laboratory took to do this. But it really exposed the innovation that is possible.
And we had to do something bold. It just couldn't be another orbiter, another this, another that. It had to be really hard. And when you compare what it cost for Viking, that was billions. Okay, now we're a factor of 20 on cost and a factor of 3 on schedule with technology that they didn't have time to develop in advance. But again, it came down to we didn't have much that year, and we needed this to be successful. So I said, take risk, but don't fail.
Yeah, well, let me talk about the background of how that was the background that Dan and Ed talked about. Remember, Dan came, I think, in April 92.
April 1st.
Then in August 93, we lost the Mars Observer. And I remember very clearly, a couple of weeks after that, I'm not sure if you remember that, Dan, I was at home. At that time, I was the director for science, technology, and instruments. And I remember exactly where I was standing. I was watering the yard. It was on a weekend. And my wife came and said, hey, Wes Huntress is on the line. I said, I wonder what it's about. So I walked in, picked the phone, and he said, yeah, he was the head of the NASA science at that time. So he said, well, I just talked with Ed Stone. Dan Goldin would like you to chair a Tiger team to look at small Mars missions. And you have only a couple of weeks to do that. Now, many of you heard about Dan Goldin, and many of you know Dan Goldin. You never say no for Dan Goldin. When he asks for something, you say, yes, sir. So anyway, we formed a Tiger team, which included JPLers, included external people, included Pete Rushton. Ed referred to the small spacecraft that the military was developing. And we met in Building 180, 101 for over a few days, and we came with a number of ideas, collectively. One of them being a lander, and we transmitted that to headquarters, and of course, Dan picked up the lander. No big surprise. But at that time, there was no rover on it. So the focus was on how do we land with a low cost on Mars, and to do it in 3 years, like Ed said. But then there was in my office a lady by the name of Donna Shirley. She was an engineer working on robotics. She comes to me and said, you remember that rover we showed you a few weeks ago? We think we can build that rover in time to put it on the mission. So of course I went to Tony Spear, and Tony said, look, I have a deadline, I have a limited budget, I have all those things, get the hell out of here. Well, as you know me, I don't take no for an answer. So I went to Wes Huntress. Wes was intrigued, but he said, well, but I don't know where to get the money. So I went to Sam Veneri, who was at that time in charge of technology. So after a little while, Sam said, well, I'll pay with the $25 million if you can get it on the mission. So I went back to Wes, and Wes told me, well, give me 20.
Sam came to me.
Yeah, well, let me continue the story. So Wes told me, give me 24 hours, and I kind of guessed what he wanted the 24 hours for. So by the time I got here, Wes must have talked with you. Dan said, this is a bold thing we want to do in addition to the landing. And that's how, and of course, when Wes said, let's go ahead, and then Ed said, go ahead, and Tony Spears said, yes, sir, move on that. And that's how the rover came about. And look at the legacies that that little rover have led to Spirit, Opportunity, Curiosity, and then Mars 2020. And that's a kind of small but visionary technology investment that NASA and Dan was very well known for that, which led us to do the great things, that we do now. And in my mind, I'm sure all of you know how much I like the Mars helicopter that is being looked at for the Mars 2020. In my mind, that's exactly the same example. It's a bold technology experiment, high risk, relatively speaking, but I'm sure you'll make it work. And I'll bet you 20 years from now, people sitting here will be talking about airplanes and balloons and helicopters flying and exploring Mars. That's the kind of thing, the kind of leadership that Dan provided at that time, which really, and then Ed, when I was a director, which really made the revolution you see today. So really, Pathfinder had a legacy, not only in the landing and the airbags, but also in the rovers that you see today.
In fact, let's look at the EDL. We have actually the very original, literally back of the envelope designs when this first came up. So if we can roll that clip, please.
Some of the original ideas for an airbag landing were these back-of-the-envelope sketches. As the plan envisioned, Pathfinder dives into the Martian atmosphere at 16,000 miles per hour. Protected by its heat shield, the spacecraft burns through the Martian atmosphere, reducing its speed to 900 miles per hour. Next, a parachute is deployed. Then the heat shield and back shell are jettisoned, and a rope drops to detect the ground. The airbags inflate. Seconds later, the lander hits the surface at 50 miles per hour, bouncing stories high. After the lander finally comes to rest, the airbags deflate, and an antenna rises up, transmitting back to Earth the news that the lander is, somehow, still in one piece.
Muirhead.
Piece of cake, Brian.
That's right. Now,
That's what I was going to say.
how did you feel about this mission when you took it on?
Well, it's interesting. I was in a really nice job at that time. I was a section manager. And I ended up talking to Charles Elachi about, well, this is a pretty crazy mission. It's not clear it's going to get funded. What should I do? He said, well, just stay where you are for a minute, a little while longer, and let's see what happens to the budget. When the budget came through, then I jumped to Tony's call. And from that point on, it was my job to staff the team that would design, build, test, and operate this spacecraft.
And there were a lot of challenges. What would you say was the one that kept you up the most at night?
It has to be. If you're going to Mars, it's always entry, descent, and landing. That's what you worry about. And of course, for us, we had to invent and reinvent pieces of the entry, descent, and landing system. The biggest invention, of course, was the airbags. And that was something that when we started out, we did what normal engineers do. We bring onboard our computers and we model things.
And we have a clip that will give some sense of that as well, if we could roll that one.
If this is the surface of the atmosphere, we're coming in and we have to...
I had never been a flight system manager. I had delivered, sizable things at the lab, but nothing like the flight system of a spacecraft. And it's the people that came around me on the flight system team we kind of accreted a team of radical kind of thinkers.
Muirhead was open to new ideas, but they had to be subjected to tried and true methods of proof.
Which is build it, test it, break it, fix it, do it again.
But not everything could be fully tested.
I was very scared of the parachute, I gotta tell you. Mostly was that the parachute was the one thing we couldn't test in any realistic way.
Assuming the parachute worked, the next challenge was knowing when to inflate the airbags, just seconds before hitting the ground. The original idea of hanging a rope with a sensor at the bottom proved unworkable, so radar was added. But that solution raised new problems.
The devil's in the details. That's where I got into the picture, was in the devil's in the details. Like, for example, in some of the drop tests, we do drop tests on parachutes, and the radar was dropping and taking measurements, and it was swinging, like you would imagine that it would be swinging, and then we realized that the radar, when it loses lock, it has all these horrible altitude measurements that the radar tells you these are good measurements, but they are really bad.
To increase the chance of a safe landing, rockets were added in hopes of further slowing down the lander.
So there was a set of steps we went through where smart people thought about how to make it more reliable, but it just kind of added more to here's something that goes into this basket and then that basket dumps into this tray. I mean, so it really gives you that Rube Goldberg sort of a feeling.
Then there were the airbags.
There we go, it's rolling off. It's going the wrong way.
I remember working with Sandia. They had the most powerful computer in the world at that time. And we brought it to its knees trying to simulate this airbag.
In the early 1990s, computer processing capability was just getting good enough that we could imagine really bringing all of these simulation programs together. But there were certain parts of it we came to realize you really couldn't treat very well with a computer simulation. The airbags being by far and away the foremost example.
I would guess that we didn't understand 90% of the fundamental physics that goes into the airbag. However, I would also argue that we didn't understand 50% at the end of Pathfinder.
So, as if you didn't have enough problems already, you had a budget problem and a schedule problem and an engineering problem.
One of the biggest engineering problems was mass, managing the mass. And one of the things we learned very early on is it's not what we can launch, it's what we can enter. And so the limit on what we felt we could enter was driven by a ballistic coefficient, and that's driven by the mass and the drag of the vehicle. So part of my job as flight system manager I took on was to manage the mass. And so every gram we were sensitive to, and we had to be very careful about. And I know the rover team remembers this, but I was always threatening the rover team, Bill Lehman sitting here, with, if you blow your mass number, I'm throwing you off the spacecraft. And I meant it, and they believed me. And one of the things I learned from that experience, and what this place does so well, when you hand them what looks to be an impossible job with impossible constraints, they get very creative. And they found the solutions to stay within the mass, to add ramps and still stay within the mass. So it was a wonderful example of how creative people can be when you give them a tough job and then give them the freedom, the flexibility to be creative about how they do it.
So you solved the technical problems, you launched on time, you launched on budget, which was probably one of the more important aspects of this.
Well, we believe
it become the poster child for faster, better, cheaper at this point.
We really believe that if we blew the budget, we'd be canceled. And everybody on the we believe you, Mr. Gold. And there were times when the bean counters, the budget guys, were projecting my budget to go as badly as my mass was going. And so we were at risk, but one of the things that was wonderful about our review board, we had Jim Martin, the Viking project manager, was our review board chairman. And when Jim spoke, people listened. And so Jim would look at the bean counters estimate and he would say, I can't prove they won't make it, so I'm going to let them keep going. And he would call back to headquarters and say, I think, don't kill them.
Viking being 20 years before, Viking coming out of Langley, being managed there, another contribution by another NASA center in all of this. So you launched, and 7 months later, we were at entry, descent, and landing on July the 4th morning, and let's see what that was like.
This is the Mars Pathfinder flight director. We are currently approximately 15 minutes away from cruise stage separation. All telemetry continues to look nominal.
EDLCom reports spacecraft ranging channel off event. EDL reports cruise stage separation.
All right, this is the Mars Pathfinder flight director. We have confirmed that cruise stage separation has occurred. All right, we will now pass EDL operations to our chief engineer and entry, descent, and landing lead, Rob Manning, who will report the real-time EDL status.
Really, there's these few minutes where everybody wants to know what's happening, and you just don't. It's scary, and at the same time, it's exciting as hell.
The spacecraft now is about 7,500 kilometers above the surface of Mars. It's still traveling at about 7.4 kilometers per second. Very fast.
We were all apprehensive. There were so many things that could have gone wrong, and everything had to go right.
30 seconds till entry. Spacecraft is now slowing down very rapidly. We expect that the parachute will deploy in about 15 seconds. Parachute should now be deployed. Separation should have occurred right about now. Airbag should be inflated.
EDLCom, a weak signal is coming in and out of the spectrum. Roger that.
What a moment. Jennifer, take us there. What happened then? What happened at that point?
Well, it was crazy exciting because everybody was screaming and jumping around. And I remember we got a call from JSC, somebody passed along that they weren't happy with the demeanor of the operations people, and that we needed to kind of take it easy and be more controlled in the mission support area. And but my job was, after landing, I was the flight director for the team of folks who had to do the interactive deployments and things we needed to do to get the rover off the lander. So one of the first things we did is we had to deploy the camera mast so that the camera could look for the sun, and then based on where the sun was, we could figure out where the Earth was and then point the high gain antenna towards the Earth, and then take and send down those very first images of Mars, which are the picture of the rover on the pedal in its hunched down position. And so I had a procedure. We were very well practiced. We'd done a lot of tests that had gone very poorly. So we had a lot of experience, a lot of contingency plans based on things not going so well to date for those kinds of tests. And the reason, one of the things about doing tests like that is not only are you trying to figure out how to do the operations on Mars, you're actually also trying to simulate the universe. And that's the hard part of those tests, where you have to get the sun position right and Mars position right and all that. And so those tests were always a lot more complicated than actual operations, which is a good thing. So initially, the very first thing we wanted to do was get those images down to see that what the landing site looked like and the rover on the pedal. And I remember getting those images down, and we were printing them out on printers, right? That's where we were at. Actually, the very first images, I think somebody had like a 30-day trial membership of a piece of software that they were watching on one of the computer screens. And so everybody was going and around their computer screen because they had sort of siphoned the images off of the image pipeline. And we saw these images of this landing site. And I remember we weren't able to, the next day was the day we drove the rover off the lander, but I remember driving home that night with that picture of the rover on that surface of Mars that was taken by that camera that Peter designed to look like a person looking out there. And I just thought, how on earth, does a farm girl from Ohio grow up to be involved in something where we are looking at another world? I mean, we are the eyes into this other world. And it was overwhelming, it was fun. And then the next day we came back and we got the rover to drive off the lander. And then the public got so engaged, and it was just a great experience.
I want to talk about the...
Could I jump in here? Because the public being engaged, the internet was just coming of itself. And although it isn't recognized, JPL was a pioneer in the huge overload that was on the internet. They thought about it in advance. The work got done. And I don't know if the world knows what an incredible communications job and computer job that they did. It was phenomenal, absolutely phenomenal, which led to the public being involved in such a large, exciting experience.
If you think about it, it's a bit like today with social media being so important, and that was a pioneering moment in the use of the internet and communicating about the space program.
We were rather primitive, though. We mirrored sites around the world where we sent the data, so we wouldn't swamp out the JPL servers. So that allowed us to get the data out around the world.
But that wasn't primitive, it was genius.
Now, the number I remember is 670 million hits over a three-month period or something like that. It was the biggest thing. It was the biggest thing. Today, that's trivial.
Huge at that time.
At that time, it was huge, and it's because all the server companies were happy to have access. I mean, this was helping them create the market for the internet. So in that sense, it really stimulated that whole area.
So there was creativity just across the whole basis.
Now, I can't let this opportunity go by, Jennifer, without telling this, at least one of the couple of stories you've told me about your interaction with Dan that day, as if you didn't have enough to worry about as a flight director. Can you at least tell one of those two stories?
Okay, I'll tell well, so as things were crazy in the mission support area and people were jumping up and down and looking at the images, and we tried to maintain some level of control, but then we lost all control, and everybody was packed into this tiny little room and people hanging over the chairs looking at the images, and I had I had a procedure that I was supposed to be executing, right? And I had a team of people who were supposed to be reporting telemetry channels to me, and we were supposed to move on and make sure we got the sequence to the end so we could drive the rover down the ramps the next day. And I got to the point where I couldn't run the mission support area, and I didn't know who was in there, and I didn't know, what to do except for to say, anybody in the mission support area who is not on console and not part of the team who needs to be in here right now needs to leave right now so we can finish our job. And it turns out Dan Goldin was one of the people who was in the mission support area. And so I kicked him out, and he left, and we got things under better control so we could finish out the activities for the day, for the sol.
You did the right thing.
Every other mission exactly the same way on landing day, right?
Yeah.
Same experience every time.
I think that was one of the great experiences I had on Pathfinder, not just that moment in the MSA, but I came, I didn't even have a job when I took the job. So I took the job because I needed a job, and also because it sounded exciting. And then I didn't really do the job I took. It was underfunded, lowly funded, and so whatever you were willing to do, it was correctly funded. It was funded such that people could be innovative and could take ownership of a whole bunch of stuff, right? And I was in my 20s. I guess, it's 20 years ago. I was 10. No, I'm saying, no. I was in my 20s, and I had nothing better to do except for this and play volleyball on the weekends, right? So I was there all the time. And I will say, the people, right? I mean, that opportunity to be surrounded by a small but insanely excellent group of people that I was able to learn from, and is what has brought me to where I am today, because I learned from Rob Manning and Miguel San Martin, and I know cruise attitude control now, and I know the surface high gain antenna pointing, and all these things, but there's a group of people, and so it really was significant the way that the structure allowed people to do as much as they were willing and able to do, and just learn an incredible amount.
I don't think you were prepared as a team for the public reaction to this.
No.
And I know it. You had a very personal kind of public reaction too, didn't you?
Well, I did, and it's interesting because I guess they played the CNN footage at some of the prisons around the area, right? And so I got letters, and was it Joe Courtney, who was the head of security at the time? I don't remember. He would just regularly come into Building 230 and deliver me a little stack of letters that were from federal prisoners, saying they wanted to go to Mars, or it was great what we did, one day I got a letter from one day they put an article in Parade magazine that just said what I had done and had a picture of me. And I got a letter from a lady in Texas who had seen that article in Parade magazine, and I put it on the stack of letters with the federal prisoners. And the letter said, I have a son who's in the Air Force, and if you were ever willing to give him a tour of JPL, I'm sure he would love to come, right? And so I put it in my stack of letters. And then probably 3 or 4 months later, I had decided to reply to all the letters. I don't know why I decided to do that. So I wrote this lady, and I said, sure, if this guy from the Air Force wants to come and visit JPL, I'm happy to give him a tour. And it turned out that day he didn't know his mom had written the letter. It was clear she was trying to set us up. But he actually had quite an interest in JPL, so he took me up on the offer, came out. He was looking at going to test pilot school at Edwards Air Force Base, came out, I gave him a tour, and 2 years later, we got married. So, so no matter what, Pathfinder's my favorite mission.
All right, moving on.
One thing I wanted to comment on that Jennifer just touched on, I think one of the great legacies of Pathfinder and the Mars program is it allowed us to do engineering the way engineering is done, which is have the same people do a mission, learn what they did right or wrong, and then do another one, and then do another one. And a lot of the same people, as Jennifer mentioned, Rob and Miguel and Richard Cook and all of these people, did Spirit and Opportunity, did Curiosity. Some of them are now doing 2020 as well. And so really an amazing cadre of engineers who spent their whole career building these Mars missions and building them the right way, building them successfully. And that has been something that's really difficult to do in the agency. You know, the fact that Mars is relatively close, so you can send missions every 26 months, it allowed us to really build up this knowledge, a knowledge base that we really haven't had for any other planet. And it's been a fantastic experience. And I think that's a lot of the secret to the success is really that. It's that ability to learn from mistakes and have the same people keep doing the work and not forget it for 20 years, as Brian said, after Viking. You know, there was nobody around really from Viking anymore, but the folks on Curiosity were the same ones from Pathfinder.
You arrived at the lab about the time of Pathfinder, I think.
A few years before.
A couple of years.
Yeah.
What kind of importance did Pathfinder had in the advancement of where we've gone?
Well, as I mentioned, I think Pathfinder really taught us two things from the scientific and from the mission perspective. I think we really wanted to do these robotic explorers. Now, Pathfinder was somewhat constrained in how far it could backpack, right, because of the base station and the way it was designed. But our other rovers really were traveling robotic geologists. And I think that's really a paradigm that we learned, and Curiosity's was the biggest investment we had, and we again tried to build on that legacy. But you go in thinking we're going to drive this thing for 2 years, and we're going to go to places we've never seen before, and that's something that really started with Pathfinder. But look around sniffing rocks that were as far as it could get, and then Spirit and Opportunity going even farther and building on that. And then I know from myself, I did not was not an engineer on Pathfinder, but being on Curiosity, being able to work with the team that had been successful on that mission and other missions, it gives you a lot of confidence. And you can sit there and go over a lot of things that can go wrong. You can think through a lot of scenarios, and it was just a wonderful experience to be able to work with a team that had that much experience on Mars. And we often went, Jennifer and I worked on Curiosity together. We would go back and look, okay, what did Mur do here? And Spirit and Opportunity, what went right, what went wrong, what can we fix? Now Jennifer's on 2020 looking at, okay, what went right on MSL, what can we do better? How can we be smarter about the operations and the engineering? And so it was just a great experience.
I do these oral histories with folks that past, present, and I almost always ask them about faster, better, cheaper, and where's the needle? Where has it gone? Has it gone too far one way or another? And it's amazing to me the number of people who say we've gone too far away from faster, better, cheaper. I hear that all the time.
I think the trick is to go back to your processes and look at what has accreted that is relatively low added value, right? So a lot of times we have ways of doing things that have built up due to conservatism and maybe not direct high value return. And we don't always go back and reanalyze those processes. So I think part of what the whole leadership team is doing is going back and looking at the way we do our work, looking at what can be streamlined, looking at where technology has advanced to where the failure modes that we used to have in electronic parts are no longer the failure modes that you have in modern electronic parts. And so you can change your process, you can streamline your processes. There's a lot of advances in software, auto coding and other kinds of things that you can do with advanced IT and advanced compilers that reduce the error count in software. So I think we're looking at where we can take advantage of new technologies, and we're asking our leadership team to go back, working with engineers, with you guys that are in the lab. You often know a lot of what steps are value added and not value added, and we want to make sure that bubbles up. And as you heard Brian say, that's a lot of what made Pathfinder successful, was empowering individual engineers in their workplace to say, this is not the best way to do this. I know a better way to do this, either because technology is advanced or because I'm smart or because I've just sat here for 10 hours working on this thing and I know what I'm doing in a single shift. And we're trying to make sure that we get that empowerment down to the lowest levels by working with the line organizations. I think what would also help us is alignment with headquarters, with the agency. So there are times at which the agency strongly advocates technology demos, Class D and Class C work, and there's other times when they don't. So Cassini, for example, is a Class A mission, or Mars 2020. These are missions that the risk is intended to be driven fairly low. But there are other times when the agency can incentivize taking chances and can incentivize streamlined processes, as they did with Pathfinder. And we're actually starting to see more of those missions coming. Charles Elachi mentioned the helicopter. That's a tech demo. It has very, very few or almost no scientific requirements, very few requirements on it. It just has to get there and take off and fly around on Mars and land and do that a few times. It doesn't have to execute a vastly complicated science mission. So that, the helicopter's a good example. There's a deep space optical comm technology demo on Psyche. There's a number of these areas where the agency is asking us to push the envelope with Class D, and we like those. And I think that's a great opportunity for folks to take a swing through a mission like that or an instrument like that, and then also take a swing through the more conservative missions, and that way you can kind of see how that, how the pointer can be set, as Blaine was saying. In this kind of mission needs to be set here, and then here I can take chances.
I've been on MSL at Mars 2020, and now to go back and talk about Pathfinder these last few weeks has reminded me of things. And it's reminded me that we can create culture by the way we make our choices, right? Whether you're on a big project or you're on a small project, you focus on the content, you focus on being excellent at the technical work, you focus on questioning things that don't make sense to you, you focus on throwing out process. And I actually told Richard, I said, I am reinvigorated to completely ignore my management.
Of which you are the management now.
Of which I am the management, so it's but, especially to the younger folks here who didn't have the Pathfinder opportunity, I think you can create that opportunity by being excellent technically and questioning. This place loves that, and I think it can come from the bottom, from the top, from the side, but it comes from the people, right? And what you do every day.
I think of Charles. You oftentimes use that phrase from Teddy Roosevelt of "dare mighty things," and part of what Pathfinder put in motion was the daring of audacious things, and curiosity being a very audacious thing to do, as well as a mighty thing.
Every explorer, they have to dare mighty things if they want to push the limit. And that's why I like that quote from Teddy Roosevelt. And matter of fact, the first time it was quoted here at JPL, Dan, remember, when I was appointed as a JPL director, he delayed the announcement by a day because he wanted to be physically here. I remember, so he came and he looked at all the employees and looked at me, and he quoted Teddy Roosevelt about daring mighty things. And now you see it all over or overlap because you need to do that. In our business, if you don't dare mighty things, if you say this is too difficult, you have given up. But as long as you really try hard to make it happen, and every explorer encountered that. Not only us, and Pathfinder is one example, of where people dared mighty things. One thing I thought Brian would be mentioning, there was another challenge above and beyond the technical challenge, is how to streamline the implementation. Remember, we were at a time when we were doing the big spacecraft and all kinds of processes and reviews, and matter of fact, some of you noted in the video when Dan was talking, there was a bunch of books sitting next to him. He was giving that as an example of what would it take to write a proposal, or do something on doing that. When I was a young investigator, my proposal used to be like 10 pages. That was in the early 80s. And one of the challenges the team had, and Tony and Brian and their team was able to do, is to work on streamlining the process. And that required a lot of support because there were a lot of antibodies, about that.
That's right. Yeah, we created a skunk works within the JPL organization. Right. But more than anything, the thing that made us successful, I think, was the fact that we trusted each other. We trusted the individuals for their skill, their ability. We did not do a lot of paper, a lot of process, and we concurrently engineered the system as we went along, and then we depended very much on a process of rapid decision making. So when something went wrong, when there was a problem, I could bring together just a handful of people, and in a matter of minutes to hours, maybe a few days, we could understand the problem and we could put a solution in place, and we go execute it. Sometimes in our big projects today, it can take weeks to months to make those kind of changes. But the relationships that were built, the definition of a high-performance team from Katzenbach and Smith was a team that is personally committed to each other's success. And I think we had that.
So that was another daring mighty things, but in a different aspect. It was in a management aspect.
One interesting part of that is, that we talk about the scientific, the programmatic legacy, the people legacy of Pathfinder, all of which were fantastically successful. I think we still, you'll get a kick out of this, Dan, and Brian knows this more than anyone, we struggle to retain that streamlined sense of innovation, because the natural tendency is to then become more conservative, make the next one bigger and better, and make it work. And I think the breath of fresh air that Pathfinder is something that's still needed, because we become more and more risk averse, as an agency.
I think you're absolutely spot on. I really challenge all of you to listen to what your director said, and don't keep doing things because they're safe. You have to lead in technology and science. Don't get complacent with success. Always be nervous and always push the limits.
Well, Dan, as usual, you get the last word. And I want to thank all the panelists for being here. It's been a very interesting hour discussion, and we're going to close out by reflecting with a video on what has happened in the last 20 years at Mars. It's very impressive. Thank you all for coming.
Standing back for touchdown.